Welcome to Chapter 7, Ionic Equilibria, Acid and Base. First, let us define what is strong acid, base, weak acid and base, pH, pOH, and pKW. Strong acid will be focusing on strong acid completely transfer its proton to water, leaving no undissociated molecules in solution. Whereas weak acid, it only partially dissociates. Then for strong base, completely dissociated, weak base, partially dissociated in aqueous solution. Okay, pH is the negative log in base 10 of equated hydrogen ion in concentration. So this is the formula that you need to remember. Okay, then for pOH is for hydroxide ion. Yes. Okay, so this one should be pOH. Okay, please correct this in your notes. Okay, another one, ionic product constant, Kw. Kw is the product of the equated hydrogen ion and hydroxide ion concentration. And the value is a constant. Okay, so we call it ion product constant. Okay, if we have P here, it means it's the negative log in base 10. Calculate the pH values of strong acid and base. Okay, it's given H2SO4, given the pH. Okay, we know that pH is a strong acid. Therefore, it completely dissociates. So when completely dissociate, we only use single arrow. And here we have 2, that's why it is 2H+. So if let's say we have 0.5 molar, so the hydrogen ion will be 2 times 0.05. And then in order to find pH, we use the formula pH equals to negative log H+. So finally, we will get 1. Okay, another question, calculate the pH of aqueous solution of volume 250 dm cube. And then this is the mass of NaOH given. Okay, so this one should be only cm cube. Okay, it's not dm cube. Okay, so sodium hydroxide is a strong base. Okay, if we want to find pH, means that we must know negative log H+. Okay, and then we also know that pH plus pOH equals to 14. Okay, so how do we find pH? Okay, so means we need to know what is pOH because sodium hydroxide is a base. So find the number of mole and then find the concentration of sodium hydroxide. Okay, because from the concentration of sodium hydroxide, we can find the concentration of hydroxide ion. So for hydroxide ion, then we can find pOH. After we find pOH, we substitute into pH equals to 14 minus pOH. Then we will get the pH of a strong base. Okay, then we see whether the answer is logic or not. Okay, strong base pH will be greater than 7. Okay, so our final answer is 12.57. So it's logic. Okay, now let us look at one example, how to calculate the pH. Okay, let's start to calculate the pH of strong acid. Okay, so if we have HCl, it will completely dissociate in water and become H plus and Cl minus. If we have 1.5 molar, okay. So this one, okay, I want you to change it to 0.5. Okay, so if 0.5, so H plus is also 0.5. So pH equals to negative log 0.5. So we will get the answer is 0.3. Okay. Okay, because pH equals to negative log H plus. Okay, another one is given KOH. Okay, KOH, we know that it is a strong base. Okay, if it's a strong base, we use single arrow because it's completely dissociate. So 0.025, if stoichiometry, we will also get 0.025 for OH minus. Okay, so in order to get pH, pH equals to 14 minus POH. So we get 14 minus negative log 0.025, and then the final answer we will get 12.4. Okay, so let's see whether it makes sense or not. Okay, KOH is a strong base, so the pH is more than 7. Okay, now HCl is a strong acid, so the pH should be less than 0.3. Should be less than 7. Okay, now next one, determine the mass of sodium hydroxide that is needed to prepare 250 dm cube. Okay, same again here, should change it to only cm cube with a solution of 13.10. Okay, same thing again. NaOH is a strong base. It will completely dissociate and becomes sodium positive and hydroxide ion. Okay, so what is given here? We need to find the mass, but only given volume and pH. Okay, so what we are going to do, we do it step by step. Okay, pH, we know pH equals to 14 minus POH. So 13.1, 14 minus POH. So POH equals to 0.9. Okay, so from POH, we know that it is negative log OH minus. So we can get from here OH minus equals to 0.125 molar. Okay, so if hydroxide ion is 0.125 molar, 1 mole, so stoichiometry, so means NaOH is also 0.125 molar. Okay, now we can start to look for the mass. Okay, we know that concentration equals to mole per volume. Okay, so our concentration is 0.125. Find the number of mole, and given is 0.25 dm cube. Okay, so mole will be equals to 0.03125 mole. Okay, now let's find the mass of sodium hydroxide. So we know mole equals to mass over molar mass. So our mass of sodium hydroxide equals to mole times molar mass, which is 40. So final answer we will get 1.25 gram. Okay, now let's highlight again what is important. Okay, when we are answering this kind of question, this one is referring to mass of sodium hydroxide. So don't just give the mass of OH only. And one more thing is the importance of stoichiometry. If let's say this is 1 mole, stoichiometry for sodium hydroxide is also 1 mole. So if we can find the molarity for hydroxide ion, we also can find the molarity for the strong base. And must remember to use, if this is a base, remember if we are given pH, means we have to relate pH equals to 14 minus POH. Okay, so that's all for this chapter. Calculate strong acid and strong base pH.